In this video, I'm going to give you an introduction to inverses, and basically inverses are just where you're reflecting a function or graph about the line y equals x. And so that's the line going through there. So if you had a graph that looked like this, then the reflection would look like that. It's almost like what you did when you were a little kid and you drew with paint on one side of a page, then you folded it together and opened it up, and you had the same reflection of that picture on the other side. And so inverses are basically just reflecting about that line. The notation for what it looks like is f to the minus 1, and that's how you know it's an inverse. It could be g to the minus 1 or any graph to the minus 1. Don't think of it as being to the power of minus 1 as much as just a notation. And then in essence what you do, what do I do with inverses? Step 1, I literally just swap the x and the y. And so I'll show you that down here mathematically. And if you're drawing an inverse, you can work out the whole inverse equation like I've done down here and then redraw that from scratch and say, how do I get an x-intercept, y-intercept, join it? But I'm just going to show you again how you can just swap the x's and y's visually. And then the second goal, once you've swapped the x and y, which is typically one of the easier things you'll do in your high school math syllabus, is then to try and get y by itself, which sometimes is easy and sometimes tricky and sometimes weird. And so I'll look through a few of these examples in different videos. And so just to whet your appetite, this is what it looks like. Here's a typical straight line graph, fx equals 2x minus 6. If I'm getting the inverse, step 1, I just swap the x and y values around, as easy as that. And then my goal becomes step 2, to try get y by itself. So I'm going to take the 6 across. I want to get y by itself, so I divide by 2. You can just write x plus 6 over 2, but I personally think it's nicer to get in the habit of making it look like you normally do with y equals mx plus c, in the sense of when I've divided 1x by 2, it's half x. 6 divided by 2 is 3. So here's the inverse. I am finished, but again, just to be fastidious and keep a good habit, if the original was fx, let me just finish by saying and showing that I'm actually doing the inverse now, also to avoid confusion later. And there I've just written the graph out again. If I was drawing the original graph, so we come back up here, so this was all mathematically what I've just showed you. Now visually, if I want the y-intercept, it's quite easy. I just let x be 0 and it's the number at the end. So here's your y-intercept. If I want the x-intercept, I let y be 0, like any other graph. I take the 6 across, divide by 2, the x-intercept is 3. So I play dot to dot, and here's my fx straight line graph, the one in green. Now, instead of having to work it out and do the exact process like I've done here of getting x and y intercepts, you could just, and this is a cool habit, if the x-intercept was 3, now in the inverse the y-intercept would be 3. If the y-intercept was minus 6, in the inverse the x-intercept would be minus 6. And then you could play dot to dot and join those to have your inverse graph. If, as a bonus question, they ask you to find that point of intersection, it's just the point where the original graph is equal to the inverse graph that you've just worked out. So you can just do it like that, make the two graphs equal. It is also the point where you've got this reflection about the line y equals x, so that could be another graph that you can make equal, just making it equal to x, just to keep that in mind. So that can also be a common question, what's the point of intersection? I hope that you found that helpful just as an introduction to the concept of inverses. If you did, please like this video, subscribe to our channel and share it with your friends, and then in future videos we're going to dive a bit deeper into this concept.